Hello. In the previous lesson, we defined the EEPROM registers, the function prototypes, and implemented the function EEPROM_init. In this lesson, you shall continue with the remaining implementation. Let's start with implementing the function EEPROM_read. The function returns the data byte read from the address in the EEPROM memory, hence defined as such. The size of EEPROM is 1 kilobyte in the Atmega 328 microcontroller. So, an unsigned integer is needed to hold the address. Let's refer the flowchart for the read operation that we discussed earlier. The very first step in the read operation is to check for the EEPE bit in the EECR register to be 0. If it is not, then wait for the EEPE bit in the EECR register to be 0. It is implemented as a while loop. The loop runs until the EEPE bit is set to 1. Then assign the address registers EEARH and EEARL with the address passed to the function. This can be easily done by declaring a pointer to unsigned character and assigning the address to it as shown. The pointer variable ADDR points to the address of the least significant byte of the unsigned integer variable address. This address is assigned to the address register pair as such. The register EEARL is assigned the least significant byte of the address and the EEARH is assigned the most significant byte by incrementing the pointer address by 1. Then the read enable bit EERE in the EECR register is set. This statement copies the content of the EEPROM memory pointed by the address register to the EEDR register. The function returns the content of the EEDR register using the return statement. Now implement the function EEPROM_write. The function needs two pieces of information, the EEPROM memory address to be written and the data. These are passed as the function parameters. The address is defined as an unsigned integer and the data as unsigned character. The function does not return any value, so the return type is void. As in the function EEPROM_read, the very first step in the write operation is to check for the EEPE bit in the EECR register to be 0. If it is not, then wait for the EEPE bit in the EECR register to be 0. It is implemented as a while loop. The loop runs until the EEPE bit is 1. The address registers are assigned as we did in the function EEPROM_read. Define an unsigned character pointer and the address is assigned to it. Then the high and the low address byte are assigned to the EEARH and EEARL registers respectively. Then the data is assigned to the EEDR register. Then the steps disabling the interrupt, setting the EEMPE bit in the EECR register, setting the EEPE bit in the EECR register, and enabling the interrupt are implemented. The interrupt are disabled and enabled using inline assembly instructions CLI and SEI. The EEMPE and EEPE bit are set by using the bitwise OR operations as shown. This is the critical section of the write function, since setting the EEMPE bit and EEPE must happen within the 4 clock cycles and no instructions should be inserted between these two statements. The erase operation is implemented in the function EEPROM_erase. It needs the EEPROM address to be erased, so address value is passed as unsigned integer. Referring to the erase operation flowchart, we see the erase operation is the same as the write operation. And the only difference is in erase operation, the data to be written is not relevant. So the function EEPROM_write can be used for erase operation, but the operating mode must be changed to erase only before calling the function EEPROM_write. We shall change the operating mode by calling the function EEPROM_init with erase_only parameter and then perform the erase operation by calling the EEPROM_write. The EEPROM memory address passed to the function EEPROM_erase is passed to the function EEPROM_write and the value 00 is passed for the data. The value of the data is not important as it is ignored. Then, the operating mode stored in the global variable mode is restored by calling the function EEPROM_init. The variable mode is passed as a parameter to the function EEPROM_init. Check for any issue that may throw compiler error. Update the makefile with the newly added source file and target file name. Append the file name eeprom.c to the source file list and the variable target. Let's name the target as EEPROM_driver. Compile and fix error and warning if any. The linker is complaining about the missing function main. We can ignore that for now. Now, let's implement the function main and code it with read, write, and erase operations to test our EEPROM driver code. Create the source file proc.c in the source directory. Include the header files res_map.h, eeprom.h, delay.h, usart.h, and util.h. We shall use the functions sprintc and sprintS to print the address and data on the terminal emulator. These functions are defined in the usart library. The functions _int to ASCII hex and _char to ASCII hex will be used to convert the address and data into ASCII characters before printing it on the terminal emulator. Initialize the usart driver by calling the function init_usart and set the baud rate to 9600. Then initialize the EEPROM driver by calling the function EEPROM_init and set the operation mode to erase and write. Let's write the addresses 00, 10, and 20 with some value, say 1A, B2, and 3C. Note, the addresses and the values are in hex. Call the function EEPROM_write with the address and the data value as shown. The only way we can check the successful write operation is by reading these EEPROM memory address and printing the data. I will implement the function print_EEPROM_data. The function accepts the address and prints the address and data separated by a colon on the terminal emulator. Define an array of type unsigned character to hold the address and data converted into the ASCII string. The function _int to ASCII hex converts the address to ASCII string and stores it in the variable tchar. The string returned is a null terminated and then printed on terminal emulator by the function sprints. Then the second call to the function sprints prints a colon and the space character. The function EEPROM_read reads the data from the address provided and stores it in the variable data. It is then converted in ASCII string by calling the function _char to ASCII hex and printed on the terminal. The functions sprintnl and sprintcr prints the new line and carries return characters respectively. Add the function prototype of the function print_EEPROM_data. Now add the call to function print_EEPROM_data with respective addresses as shown in the function main. Then add function call to EEPROM_erase with the addresses written earlier. It should erase the data in the respective address and the value should be FF in hex. And call the function print_EEPROM_data with the addresses erased to verify if the EEPROM memory addresses are really erased. Finally, the return statement with value 0 as we have defined the function main to return an integer value. Check the code for typos and syntax error. Add the newly created source file proc.c in makefile and compile with the command make. Flash the development board using the command makeflash. Start Terraterm if you are using Windows Development PC or Screen if you are on the Linux machine. So, as you can see, the addresses 00, 10 and 20 are written with the values 1a, b2 and 3c respectively as seen in the first three statements. Then the remaining 3 line shows the data after erase operation. All the addresses are reset to the value FF in hex. These basic tests shows the driver implementation works as expected. With this, I conclude this lesson. See you in the next lesson. Till then, happy learning.